Now let's look at two population means, and I'll leave it to you to do the two binomial proportions. It's really the same concepts, and look at an example, and you should be good on that. So this begins the concept of comparing two different situations, and we'll get into more of that later in the next section. So for now, though, let's suppose we have two sample means from different populations. Okay, so let's look at that. So suppose we sample two, I'm just going to zoom in a little bit here, two population means of different populations. But related, all right? So not just entirely different, like they're related somehow. The numerical value, the statistic is the same type of value. You'll say, but related. All right, so for example, let's give you an idea of that. So for example, you have like two diet plans, and you're looking at like weight loss or something, or weight gain, whatever, doesn't matter, okay? But that numerical value is the same of what you're looking at. Same type of quantity, not the same value, obviously. Same type of quantity. So two diet plans. What else did I have here? I always try to think of physics stuff. Density of two substances. Substances. So you have, two manufacturers making the same thing, same, metal bar, something like that. So you're looking at the density maybe. You can also do this where it's more qualitative, and then of course the scoring system makes it into quantitative. You could look at that. So you could look at likelihood, or else I wrote down what likability on a rating scale. Of something, like of an artist, musician, painter, whatever, actor, whatever, artist of some sort. Likability, so that you can see that the numerical value has this, it's the same quantity, same units. So it has to be like that, or it could be unitless, but that's what we're looking at. And you're comparing them. So how would we want to compare them and analyze them? So one way to do that, this is how they do it, is you subtract them. So if in general there isn't a difference, so let's just look at like diet plans. So in diet plans, if there isn't a difference in which one's better, and you subtract them, what should you get? Well, if there isn't much of a difference, you should get 0, right? So if you're not getting 0, then which one are you getting more of? Like which one has the better, are they similar? That's really what all you're looking at. All right, so what we do is consider, let me back up. Okay, so this is what we're looking at, like the chart. This is out of the book, one of the books. Suppose you have two different populations. This is the actual mean and variance, and easily calculate the standard deviation. Anytime you have variance, you have standard deviation, same thing, or a similar thing. So you have two actual means of the populations, but you don't actually know them. Like, a good example would be, Density of substance, you can't test everything. Diet plans, you can't necessarily test everybody on it. That kind of thing. So you have the actual, so then you do the samples. So you sample the mean, variance, and of course that implies standard deviation. So always put that in there. I don't know why they even say that, because really it always boils down to standard deviation in most cases. Anyway. And you have to look at, in each case, your sample size, which might be different. And in general, you'll want those greater than 30 because you don't know, or you may not want to assume the population is normal. Okay, so remember all that kind of stuff. Okay, so now how we will look at this is we will consider the difference of them. So consider the difference between your first sample mean and your second sample mean. And so that difference is x1 minus x2. And we're really not concerned which one's first, which one's second. You're just going to look at, is it within that interval type of thing. So we're still looking at interval. We'll create an interval between of the difference. So the question is, how does this resemble the actual difference? The actual difference is mu1 minus mu2 for the population. Okay, so then you use the concept again of the sampling distribution of the difference. So we use the sampling distribution of the difference. If they are the same, like there's almost no difference, it'll be really small and close to zero of the actual. Maybe it would be zero because it's really the same. But that's what you're trying to investigate. Okay, so we'll look at the sampling distribution. Sampling distribution. Okay, so it's a similar statistic. It has to be similar. If close to zero, there is no difference between them. Okay, let's write that one down. So if close to zero, there is no difference between them. So that's what we'll be looking at. And basically, the punchline is as the ones above. Up here, the punchline is if you look at the difference between them, let's see, let's go back to this one. Is zero, or no, not those. Is zero in the, that's what we're doing now, is zero in the interval? If zero is in the interval, then it's a possibility that there's no difference between the means, and then they're practically the same result. Okay, so that's what we'll look at, and you can look at the rest of those and do the calculations. So let's look at the confidence interval. So same thing as before, 1 minus alpha times 100% confidence interval. Confidence interval. Mu1 minus mu2 looks like this. So we're going to skip all the little details and just get right to it. You take this test statistic, which is x bar 1. Oops. So the first sample minus the second sample plus or minus z sub alpha over 2, and then that'll be the 1.96 or higher if it's a different z-score, different confidence. And that's S1 squared divided by N1 plus S2 squared. So this is the variance divided by N2. So that's the formula. None of these you have to memorize. I never make you memorize these even in a regular class. You would just need to be able to use it, basically. So that's your confidence interval. And then you just put the when you subtract the standard error, you put that on the left. When you add, you put it on the right of the interval. That's really all you do. Okay, so take a look at that. I'm going to leave the example, which I'll copy in next, up to you. So let's put in the example next. I'll copy the question, which is down here somewhere. Okay, so here's the question. Let's copy that and paste in the example. Pretty straightforward after that calculation. We're going to paste the whole thing. Okay, and I'll read it first and then try it. And then I'll paste in all the details that are in my notes. To compare the effect of stress in the form of noise on ability to perform a task, 70 subjects were divided into 2 groups. The first group had 30 subjects, that's your N1, act as a control group, so there's no noise pumped in. Well, the second group had 40, right? It's a different N, greater than 30, but a different N. Perform the task in the same control room. Each experimental group subject to different loud rock music, which may or not be distracting to you, but that's what they're testing. The time to finish the task was recorded. So this was what was recorded. And so your X1, X2 are these. It's the minutes. So notice how the units are the same, right? So it's minutes. And then, of course, your standard deviation has to be the same too, and we'll just be squaring those. Okay, so find a 99% confidence interval for the groups. So you can look up just how to do that, or we will do it in the book or the tables. So you go to z-score 0.99 and look at, you find 0.99, look up the value. So we'll talk about that at some point. Okay, so that's your question. Let's see if you can calculate that. I will do some of it, actually. No, I just decided. Okay, let's do this part. So because I haven't done this part yet, the 99%. So if you say 99%, that equals your 1 minus alpha. Okay, so that, if you solve for alpha, that's equal to 0.01. So how you do that, I will show you. So you get 1 minus 0.99. That is equal to your alpha, which is equal to your 0.01. So you can add alpha, subtract the 0.99, get the 0.01, and then you will divide by 2 to find your z-score. Okay, so then over here, you do alpha over 2, which is your .01 divided by 2, and you get, I guess I don't have space, do I? Let's fix this. I'll do it down here. So alpha over 2 is your 0.01 divided by 2, and you get 0.005. Okay, so that's your z-score that you will look up. All right. So let's go look at that. So you do z sub 0.005, and what you get, I'll show you this now. So you go to your tables, and here it is. So you go to the bottom table, you ignore the negative for a second because remember it's a summed from left to right table. So you go down, you're just looking at what that piece is, not the sum of all that. That's what the table does. So you're looking at your 0.005. But if you look at your data, your table, this table, you don't have 0.005. You have 0.0051 and 0.0049. So what you do is what's called interpolating. So you interpolate between them. So it's 0.0 or 2.507 and 2.508. So you average the middle. So it's what you use in actual cases is 2.575. So that's what we will use. So your z-score for 0.005 is actually 2.575. Okay, and so what you're end up doing is what's called interpolation. So you interpolate 0.0051 and 0.0049. And if you use just 2.58, you're fine. It's not going to really matter, but that's really what you do. So to interpolate that, it's the average. And so it's 2.57 plus 2.58 divided by 2, and you get that 2.575. Okay, so that's what I wanted to show you. Let's see where I'm at. The rest, so you want to write down all that information in the notation that we're using and then do the calculation. Okay, so try that. Oops, I don't want to go back to the table. Go back to that. And this is what you get. And I'm going to correct this in my notes. This should be 1 right there. Oops. 0.01. Okay, that's in the notes. I guess by the time you see it, it'll be fixed, but but that's what I have. All right, so this is what you need to write down. Write down all your information that's to the left in the table. So we're going to put that over here. So write all that stuff down. And I'm not sure I have room for this. We'll just shrink it and put it up here. And then write down and then do your calculation. So here's your calculation. Okay, so I assume you have done all that. Okay. So there's your calculation. You just basically plug it in, you get that, multiply by your z-score, and you get that. And then you do your plus or minus. Okay. And so notice that 0 is in here, so there may not be a difference in the calculations because of the data. It looks like there is a difference, so from there you pretty much want to test further. This might give you evidence because this is so low here. It's like skewed, the 0 is skewed, right, to the right. More values are negative, so maybe more, and it's pretty obvious by the actual data. So that might give you reason to continue the study. You know, that's kind of how you do things. But it does not imply by the data specifically that there's definitely a difference. And that's how you interpret things in statistics. Okay, binomial proportions next. You can go on to that. And there's an example there. There's a large example from a different book you can take a look at and see how it's done. All right, from there we move on to the next section.